Today we're going to do the product rule and the quotient rule. So if f and g are differentiable, we say that the derivative would be the derivative of f times g plus the derivative of g times f. Now, when I'm thinking about taking the product rule, I'm not literally saying my whole function f. I'm literally saying my first part, or the first binomial, is going to be your f, and the second part will be your g, right? So let's take the derivative of the quote-unquote f. So what do? We do 5 times 2 to x of the 2 minus 1 plus, what's the derivative of any constant? It is always going to be 0, right? So this will give me 10x, right, and nothing left. Then the derivative of my g would be what? Well, this would be 2 times 3, right? And this would be x to the 3 minus 1. Well, and then minus 3 times, technically this is an exponent of 1, and x to the 1 minus 1. So this is 2 times 3, which will give me 6x squared minus 3, right? Because anything to the 0 power is always 1. So technically this is the derivative of g, and now this is my derivative of f, right? So if I now use my product rule, I can plug everything in. So this will give me 10x times g, what's my original g? That would be 2x cubed minus 3x plus the derivative of g, right? Which will be 6x squared minus 3 times, what's my f? 5x squared plus 7. So now what do I need to do? I need to distribute. So this will give me 10x to the 4th minus 30x squared plus, I have the actual FOIL, 6 times 5 will give me 30x to the 4th plus 42x squared, not plus, minus 15x squared minus 21. Okay? So now, I guess I gotta erase this and come back. Now I must combine my like terms. Well, I have a 10x to the 4th and a 30x to the 4th, which gives me a 40x to the 4th, right? I have a 30x squared and a 42x squared, and that will give me a plus 12x squared. Then I have, oh, wait a minute. I have one more, right? This 15x squared. So that'd be minus the 15x squared, which now gives me 40x to the 4th minus 3x squared. And then I finally do my minus 21. So now that I've combined all of my like terms, the derivative of all of this is 40x to the 4th minus 3x squared minus 21. So shall we try another one? We surely can. So I'm not sure what I had up there before, but we'll roll with it. So let's say y equals to 2x cubed minus 3 times 4x squared minus 2. So again, if I'm going to take the derivative of this, I need to find my derivative of f, and I need to find my derivative of g. So the derivative of this would just be 6x, and the derivative of this would just be 8x, right? 6x squared, my apologies. So the derivative would be, again, derivative of f times g plus the derivative of g times f. So the derivative of f is just 6x squared, and I write down my original g, which is 4x squared minus 2, plus my derivative of g, which is 8x, times my original f, which is 2x cubed minus 3. So I need to distribute. So this will give me 24x to the 4th, right? Minus 12x squared. then distribute the 3. This will give me a plus 16x to the 4th, right? And a minus 24x. Now I get to, again, combine my like terms. So I have a 24x to the 4th and a 16x to the 4th, which will now give me a 40x to the 4th. I don't have anything else x squared, so I just bring that down. And that makes it a 12x squared. I don't have anything else that's just with an x, so that makes it just 24x. All in all, this all means the derivative of y is 40x to the 4th minus 12x squared minus 24x. And again, as we talked about, if you do not indicate with the prime or this little asterisk above, I do not know if you are taking a derivative or not. Now, let's move to the quotient rule. The quotient rule is a little bit more intricate, maybe. So the quotient rule says if you have f and g are differentiable, right? D sub x, right? D sub x, or f of x over g. The derivative would be the derivative of f times g minus f of x times the derivative of g all over gx squared. So it's very similar to the product rule, but I think the only thing is just swapping around the g and the f, right? And then we divide by the gx squared. So again, if I use my example here, I have 9x minus 2 and a 2x plus 5. Now, again, I am not saying that my f and my g are actual functions, even though I labeled the function as what? A g of x. I'm saying the top part is your f and the bottom part is your g, right? So I need to find the derivative of f. Well, the derivative of 9x minus 2 would just simply be 9. And the derivative of g in this case would simply just be 2, right? So now I plug it into my formula of how I'm supposed to solve for it. So the derivative of f would be 9 times g. What is my g? My g is the 2x plus 5 minus f of x. What is my f of x? The whole 9x minus 2, right? Times, my derivative of g, which just would be 2, all over g squared. So what is g? That'll be all over 2x plus 5 squared. Well, I need to distribute at this point, right? So 9 times 2 will give me a lovely 18x, right? 9 times 5 will give me a lovely 45. Then I need to distribute this way, right? So 2 times 9, right, will give me a minus 18x. And 2 times 2 will give me a negative 4. However, I had a minus sign, so I need to pull that out, and that becomes a plus 4. All over my 2x plus 5 squared. So you see what you can combine together here. Well, what happens? The 18x cancels out, and then now I'm left with 45 plus 4. 45 plus 4 is 49, and then this leaves me with 2x plus 5 squared. So then that is it. This is my derivative of g of x, right? And again, make sure you indicate that you're taking the derivative. All right, so let's do one more, maybe something a little bit more intricate. For the last example, if I have y equals to x cubed plus 2 divided by x squared plus x. Again, this is your f and this is your g, right? So the derivative of the top would be 3x squared, right? And the derivative of the bottom will be 2x plus 1. If you're still working on trying to find derivative, it will be a little bit challenging. All right, so we take the derivative of the top. So what am I doing? Y prime. So the derivative of the top, which is 3x squared, times the bottom, which would be x squared plus x, minus the derivative of the bottom, right, which will be 2x plus 1, times the top. I don't have enough room. X cubed plus 2. All over x squared plus x squared, right? So I gotta erase some stuff since I don't have enough room. So if I distribute this, this will give me 3x to the 4th plus 3x cubed minus, well, if I work this out down here for you guys, it's just a second. I actually have to what? FOIL. So 2x times x cubed will give me a plus, what? 2x to the 4th. Then this will give me a plus, not 2x, 4x. Then this will give me a plus x cubed. And last but not least, plus 2. Right? So then I still need to distribute the minus sign. So we have 3x to the 4th plus 3x cubed minus 2x to the 4th minus 4x minus x cubed minus 2 all over this x squared plus x squared. Right? Then you see what you can combine together. Well, I have a 3x to the 4th and a 2x to the 4th, so that just gives me x to the 4th, right? I have a 3x cubed and a negative x cubed, so that would give me a plus 2x cubed. Then last but not least, nope, I got 2 more. Minus a 4x and then minus a 2 because there are no other terms. So then this is all over x squared plus x squared. Now, the question is this the fully simplified form, Ms. Parker? It surely is. We only need to see if we can go a little bit further, if we can factor and cancel out. And we cannot do that in this case. So that will be it for the quotient rule and the product rule. We will go over more derivatives such as sine and cosine the next time. Thank you.